Electrolytic dissociation is the separation of an electrolyte into a positive ion called a cation and a negative ion called an anion. The dissociation of an electrolyte can be represented by a chemical equation where the electrolyte is the reactant, the cation and anion are the products, and are found in the aqueous phase. The cation and anion are accompanied by their respective charges. Note that the sum of the charges of the cation and anion must be zero. To write the chemical equation for an electrolytic dissociation, follow these steps. Write the chemical formula of the electrolyte, its phase subscript, and draw an arrow to the right. Separate the electrolyte into its cation and anion. Determine the respective charges of the cation and anion, then write them as superscripts. The aqueous phase of the ion is written as a subscript. If the electrolyte's chemical formula includes subscripts, these become the ion coefficients. Calculate the sum of the charges. Here's an example of how to write a chemical equation for an electrolytic dissociation. So our example is looking at to determine the chemical equation for the electrolytic dissociation of the solid compound magnesium chloride, or MgCl2. First thing I'm going to do here is write my electrolyte. So MgCl2, and I need to make sure that I write the phase that it's in. So we're in the solid phase. Next, I put in my arrow, and to the right of that, I'm going to put in my cation and anion. So I have magnesium, and I have my chlorine. All right, I'm going to have to figure out the charges now on my cation and on my anion. So I'm going to take a look at the periodic table. And as you can see here, my magnesium is found in the second group, which is the alkaline earth metals. And so it's going to have a charge of 2+, where chlorine is a halogen, and it's in the 7A family. It's going to have a charge of 1-. But since it's a 1, I don't actually need to write that. I can just write negative, and that will be sufficient. Now all I have to do is make sure that I don't forget that they're in the aqueous phase. So that tends to be a little step that gets put to the side. So I'm going to put that in there right away, aqueous. And I've got to make sure that I've got enough of the element. So I notice that I have a subscript of 2 here for the chlorine. So I'm going to have to put it as a coefficient here on my chlorine anion. Last step is just to make sure that all my charges are balanced. So I'm going to just double check that I have 2+. That means everything's got to add to 0. So if I've got a 2+ charge on my magnesium, I'm going to add that to the -1 charge on my chlorine. But this, of course, is actually put it with a superscript. Sorry. There we go, just like that. And there's 2 of them. So I'm going to multiply that by 2. This should be getting me to 0. Let's just take a look. If I have 2 positive plus 2 negative, I have an overall charge of 0. So everything balances and we're good. We're going to determine the chemical equation for the electrolytic dissociation of the solid compound Ca3N2. So I'm going to start by writing my electrolyte, which is my Ca3N2, right up there. That's in solid phase. So I'm going to put the S, the phase right there as a subscript. And then I'm going to draw my arrow, and to the right of my arrow, I need to put in my cation and my anion. In this case, calcium is my cation, and nitrogen is my anion. Both of these are in aqueous phase. So I'm going to put that in right away so that I don't forget it. That is a step that we often forget. So now that I've got everything set up, I need to figure out the charges. And to do that, I need to look at my periodic table. Now, if I take a look, I can see that calcium is an alkaline earth metal. It's in the 2A family. So that often has a charge of 2+, which I'm going to put in right here. Meanwhile, nitrogen is over here in the group 5, which often has a charge of 3-. So I'm going to stick that charge right up here. Before I go any further, I just have to check my original electrolyte and make sure that my equation is balanced, which I can see that I have a subscript of 3 here. So I'm going to need to put 3 as the coefficient on my calcium. And I have a subscript of 2 on nitrogen, which means that it's going to come over and become the coefficient on my nitrogen over here. So just remove my periodic table and I'm all ready to go. I've got everything finished, but I do need to make sure that my charge is balanced. So a quick calculation of my charges to make sure that everything checks out is always good practice. So I see that I have 3 calciums. That means I have 3 times the 2 plus charge. And I'm going to add that to my 2 times the 3 negative charge for the nitrogen. This should give me 0, but I'm going to still go ahead and calculate it. 3 times 2 plus, of course, gives me 6 positive. And 2 times 3 negative gives me 6 negative, which is most definitely an overall charge of 0. So everything checks out and we're good to go. This time we're going to be determining the chemical equation for the electrolytic dissociation of the solid sodium nitrate, or NaNO3. The first thing I've got to do here is, of course, write the electrolyte in question, which is our sodium nitrate. So NaNO3 is going to be put here. It is in solid form, so I want to make sure that my phase is written as a subscript beside. And then I'm going to be preparing myself to write my cation and my anion to the right of the arrow. Now, in this case, I have my sodium as my cation, and I have a polyatomic compound here. So polyatomic ion right here. So the NO3 is going to spice things up a little bit for us. All right, so first of all, before I go any further, I just want to make sure that I get my correct phases. So they're both in aqueous phase. So I'm going to put that in right away so we don't forget it. That's often a step that is forgotten. And after that, I'm going to take a look. Because it's polyatomic, I actually get to look this up on a table. Your teacher may have provided you with one already. You can see here that some of the common polyatomic ions have been listed here. And the one that we're interested in, of course, is the nitrate. So it's got a -1 charge, as you can see, according to our table. So I'm just going to add that here to my ion. Next, sodium is not polyatomic, so I can just get that right off the periodic table here. And you can see that it's part of the alkali metals at the end. So that's group 1A. And so it tends to have a charge of +1, which I just write as plus here. Now, I want to check and make sure that everything is balanced, and so that I don't have any coefficients that I need to be putting in there, and everything looks okay. I've got 1 sodium, 1 nitrate. So all I need to do now is make sure that my charge is balanced. So taking a look at this, I have a +1 for my sodium. So I'm just going to write 1 plus, and I'm adding that to a -1 for my nitrate. And so overall, this gives me a charge of 0, which is exactly what I'm hoping for. So we're going to determine the chemical equation for the electrolytic dissociation of the solid sodium nitrate, which is CaHCO3 2. I'm going to start by first writing my electrolyte, which is the CaHCO3 2, up here. And it's in a solid phase, so I'm going to make sure that that is also written in. Now, to the right of the arrow, I've got to put in the arrow, and then to the right of the arrow, I'm going to write my cation and my anion. And calcium, that's pretty straightforward, but we've got a polyatomic ion right here, so which is our bicarbonate. So I've got to make sure that that is in also. All right, just erase that little bracket. I don't need it anymore. But what I do need is to make sure that we've got its phase. And the phase for calcium is aqueous. For the bicarbonate, it's also going to be aqueous. I don't want to forget that later on, so I'm going to put it in right away. I'm ready to put in the charges. So I'm going to have to look up my bicarbonate. And of course, here's the polyatomic ion list, are the typical ones anyway. And the one we want to focus on is the bicarbonate. It's got a -1 charge. So I'm going to put that up here next to my bicarbonate. Now I'm going to look at my calcium. Sorry, a little pause there, but I'm going to look at my calcium. My calcium is going to be coming right from the periodic table. So if I take a look at the periodic table, I see that calcium is in the alkaline earth metal group, which is in the second family there. And that typically has a 2+ charge. So I've got my charges there. And I just have to take a little check at my overall equation and make sure everything's balanced. Now I can see that over here I have 1 calcium, but I have 2 bicarbonates. So I'm going to have to go and put that 2 bicarbonate over here in as a coefficient to make sure that everything balances out. I'm ready now to make sure that my charges balance out. Now that my equation works. So a quick look at my charges. I want to make sure everything gets to 0. So I have 2+ for my calcium. There's only one of them. And I'm going to add that to 2 bicarbonates. And those are both with a -1 charge. So it should give me 0, but I just want to make sure of that. So 2+ plus 2 negative will give me an overall charge of 0, which is exactly what I want, and I am good to go.